get started. See effect there? Okay, good. All right, so somebody had asked that I go over exam 2, 2014, number 4 and 11. So I'll do that first. This is 2014. Number 2, and then number 11. So number 2, I have 2 vectors. This is 2014, right? Yeah, 2014, 2 and 11. 2 vectors, I want to find the sum of them. You will have a question like this, by the way, where you have to find the sum, the numerical sum of 2 vectors. So in this, the first thing that you do is you find the x and y components. So ax, ay, bx, by. Ax is equal to 10 cosine 30. Which is 0.87. Ay is 10 sine of 30, which is equal to 0.5. I want to make sure that my signs are correct on this. I like to draw a picture. So A is 30 degrees above the negative x-axis, so that's the vector A. So which of those components should be negative? The x component, thank you. All right, so the x component should be negative. And then B is 10 units along the negative x-axis, so that's B. So that means that Bx is equal to negative 10. Okay? And actually, I made a mistake here, y'all. This should be not 0.87, but 8.7. This is negative 8.7. And then here, this is not 0.5, but it's just 5. So get rid of that point. 10 sine of 30 is 0.5. Or, excuse me. Sine of 30 is 0.5. 10 sine of 30 is 5. And then Bx is equal to negative 10. I want to know the magnitude of their sum. The next step is to add up the x components to get Rx. Rx is going to equal to Ax plus Bx. That's negative 8.7 minus 10. That's negative 18.7. And then Ry is just 5. And then to find the magnitude, I say negative 18.7 squared. Though, as I've told many of you, I tend to just not write that negative at all, because unless you put that in parentheses in your calculator, it's going to come out wrong, because it's going to do the square first and then negate it, and so you'll wind up with a negative number there. So just don't include the negative. If one of your components is negative, just make it positive in your calculator. It'll make your life easier. Plus 5 squared, that's a 5. The answer then should be 19.3. Pretty sure that's 19.3. Okay? You will have a question like that, either finding the magnitude or the direction of a vector. And actually, I see that wasn't the question that the student asked, but it's still a good question because you will see it. And also, if you notice, on more recent exams, I don't have these types of questions because it's in the free response, but I have dug back into the earlier exams to pull a question like this. Okay? All right. This person actually asked for number 4, which you'll see one like this as well. Number 4 is fired horizontally. And I want to know, like, there's some desks. No, go get a desk in 248. It's just 2 doors down. Grab a desk and just bring it in and set it in that back door. So it's fired horizontally. So V0, that's all in the x direction, is equal to 10 meters per second. And then I want to know its speed after 1 second. So t is equal to 1 second. I want to know its speed. We've done problems similar to this where, let's say this is 1 second. Sorry, my pen's not working very well today. But I want to know the velocity at both of those times. That is, I want to know what Vx is here and Vy. Vx is going to be equal to 10 meters per second because the velocity in the x direction doesn't change. So Vx is equal to 10, and then I need to figure out what Vy is. I can find Vy. That's equal to V0y, which is 0, plus Ay times t. So that's going to be 0 plus negative 10 times t, or negative 10 meters per second. I let t equal 1. A is negative 10. that tells me my Vy. So now if I want to know the magnitude of the speed at that point, it's going to be the square root of Vx and Vy. That's 10 squared plus 10 squared. That's the square root of 200. Right, 14. So C is the right answer there. You will have to work a problem where you have horizontal launch. You shouldn't be surprised by that. You'll have to work a problem too where it goes up and comes back down again. Okay? So those will be multiple choice. As with this problem, or the vector problem rather, I don't have many of those going up, coming back down again to the same ground level in more recent exams because I've moved that into the free response. So you might have to dig back into the last decade of exams for questions like that. But make sure that you practice those, going up, come back down again. Because I want you to know that since it's going to be on the free response. Okay? All right, and this person also asked for number 11. These are good questions, by the way. Okay, we did this in, oh, that's number 10. Number 11, don't worry about number 11. I asked that once, I never asked it again. So let's not worry about that at all. Okay? Y'all have specific questions. Those are questions that students had asked prior to coming. Specific questions? All right, y'all be thinking about it. I will, let's just do some chapter 2, or chapter vector questions, and then we'll do some projectile motion. So you will have one like this, where you're doing the graphical addition of vectors. In this case, for example, it's a plus 2b. Make sure that you look very closely at what I'm asking here. You might have a negative, you might have a scalar like I have here, where I'm doubling the size of b. In this case, there's no negative. I'm just adding a. So first, I draw a, and then 2b. And 2b would be 1b, 2b. Notice the way that I draw them. I draw the tail of this vector to the tip of this vector. I don't draw it here, tail to tail. I draw it tip to tail. Okay? So make sure that you draw it in that way. And then also, another important thing to get this right is that you start where the vector starts and you end where the vector ends. So that tells me that the answer is going to be B. Okay? Students often, well, the things that they'll do is they'll draw a vector like that, and then they'll draw vectors like that, and then they'll get an answer like that, or all sorts of different things that you can do wrong. Just make sure that you draw the vectors in their order with the tip of one to the tail of the next, and then when you draw the resultant vector, that you start at the beginning and end at the end. Okay? You will see some like number 4 where you have graphs. You shouldn't be surprised, by the way, by the quiz because it'll look a lot like what each of these exams look like for chapter 3, for projectile motion and for vectors. So you have a projectile that's launched horizontally from a cliff. That means that it looks like this, launched like that, and I want you to tell me what happens to the y position. So this is the y position versus time is going to be the same as an object that's just dropped from some height and goes down that height. You can think about what the velocity in the y direction does. Here, the velocity in the y direction is equal to 0, and here, it's big and negative. So you're looking for a slope that starts out at 0. That would get rid of, by the way, this one and this one, because those both have big slopes to begin with. And then I need to look for one that increases in the negative direction. So which one is that? It's C, right. So C is the right answer for that one. You will see one like that. Let's do this one. This is sort of a more typical horizontal launch problem. I want to know first, the first thing to do is to find the time. Remember to find the time on these, I just imagine something dropping and ask how long does it take for that object to drop through that distance. So I say y equals 1/2 a t squared. That's negative 125. It's important that you get that negative. Is equal to negative 5 t squared. That means that t is the square root of 25, or 5 seconds. I know that looks like a 6. I'm sorry, the pen on this computer doesn't work very well. The next thing you should do, now that you know the time, is you just calculate x. To calculate x, I say x is equal to vx times t. Vx is given, that's the 20 meters per second. So 20 times 5 is equal to 100 meters. What, Jamilda? Oh, why is the height negative? Yeah, so the height is negative because you're starting at 0 and you're dropping 125 meters. If you miss that, and if you don't get that negative, when you try to do this calculation, you'll find that you'll have a square root of a negative number. And if you ever encounter that, that's probably the mistake that you made. That's when that most commonly happens. So if you ever encounter, oh, I'm taking the square root of a negative number, go back and revisit your y displacement because that's probably what you've done wrong. Okay? Students don't usually miss it for that reason. Other particular questions that you want to try? So you know how to find x components, y components. Particular questions? On this exam?
Yeah.
This one?
Yeah, like those wordy ones.
Okay, well, number 11 is chapter 3. So, but we can do by number 3, for example.
Yeah.
Yeah. You'll definitely see a couple of those. I like those kinds of questions, don't you? You like them, right? Y'all like them? Oh, thank you, Dave. Okay. I like Gabe more than Symphony. Mm-hmm. I'm just joking. I like all y'all the same. So a soccer ball is kicked with an initial speed at an angle theta. Which of these following statements is true? So just step through each statement and think about them. And then as you find a statement that you know is absolutely wrong, go through here and it'll help you to eliminate some of the things. So the acceleration of the ball is 0. Look, words are really important. I could have said the x acceleration is 0, and that would have been correct. But just saying that the acceleration of the ball is 0, not correct, because it does have a y acceleration. So that one is not correct. So then anyone that has 1 in it, I can get rid of. The speed of the ball decreases as it travels upward. So again, words are really important. The x velocity remains constant. The y velocity does decrease as it goes up. So the overall speed of it does what? Goes up or stays constant? Or goes down? It decreases, right? It slows down. Like it physically slows down as it goes to the top. So that is correct. 2 is right. That gets rid of, well, now I know the answer, right? I have 2 that I'm pretty confident of, but let's just go through. The horizontal component of the velocity is constant. Yeah, that's correct. 3 is correct. And then this should be wrong. The acceleration of the ball changes direction at the top of the trajectory. That is not correct. In fact, if I think about my Vy versus t graph for this motion, it looks like that. This is at the top where the velocity is 0. Notice the slope of the graph at this point is still negative 10. Is negative 10 across this entire graph. Okay? I like those questions because it tests you on many different angles, but I know that they can be difficult. Go through in that way, picking out the things that you know to be true or not true for sure, and then select the answers that way. That'll really help you. That's a good test taking skill too. That's fall 22. Don't worry about the free response. Is that serious? Okay, let's see. Let's go and do one that is, let me go back to like fall 18. Fall 19 is when I started doing free response. So I don't think I had any. Okay, this is fall 17. Let's look at this one. This is our typical projectile motion problem where it starts at ground level, goes up, comes back down again, ends at ground level. So I have a scenario where I have an object that goes up and comes back down again like that. The first thing I want to do is to find the x and y components. I'm going to do that up here of the velocity. So v x is equal to 40 cosine of 30. That's equal to, we'll just say 35. And then v naught y is 40 sine of 30. And that's equal to 20. Okay, so those are my x and y components and my velocity. The next step is to find the time. To find the time, I imagine up at the top where vy is equal to 0. And I say vy at the top is equal to v naught y plus ayt. That's so messy. I'm so sorry. So that's equal to 0 is equal to 20 minus 10 times t. Can y'all read that at all? All right, 0 is equal to 20 minus 10 times t. So that tells me that t is equal to 2 seconds. All right, and now, oh, that's the answer then. So the time to reach the maximum height is 2 seconds. If I was to ask the total time, it would be 4 seconds. If I needed to know the height at that time, I would say y is equal to v naught yt plus 1/2 at squared, and I would use this time, and then the x range would be, vx times t. Where I'd use what for the x range? What would I use for the time? 2 seconds? 4 seconds? Whatever. I would use 4. I'd use the total time. I think we've done those a number of times, but I do want to make sure that you can do those because it's going to be a big deal on the test. All right. Notice here on this question, I have 3 problems that followed it. That was sort of the precursor to when I did free response. So now you do that basically in the free response. It's just without multiple choice answers. All right. Other particular questions? I know y'all have class soon. Particular questions? Y'all feeling okay for this quiz? This is a harder quiz than the first quiz, so hopefully you're well prepared for it. Yeah, Tyrese? Number 10 on fall 23? All right. I think this is fall 23. Yeah. And number 10. Okay, good. Yeah, so we did a problem that was similar to this in class, right? This is the one. The vector of magnitude 3 cannot be added to vector magnitude 4. When I'm looking for one of these, like what is the resultant of these two vectors, usually what that means is I'm asking you to find the maximum and the minimum of each of those vectors, the sum, and then the answer is going to be not in that range or in that range or whatever. Here I'm looking for one of these that cannot be the sum of these two vectors. A 3 and a 4 vector can be added in a number of ways. I could have the 4 vector and the 3 vector in that way, which would give me a sum of 7. Or I could have the 4 vector and then the 3 vector, and then the magnitude of that vector, that sum, would be this vector, which would have a resultant of 1, or a magnitude of 1. So that means those two vectors can be added in a maximum way to get 7 units, or in a minimum way to get 1 unit, or anywhere in between, right? I could have the two vectors added like this, and they would have some sum that would be in between 1 and 7, but not less than 1, not more than 7. So that means that E is the right answer, that you cannot add those two vectors in any way to get a resultant that is equal to 0. Okay? Other particular questions? Yeah, Abigail? Fall 22? Sure. Number 2. Okay, so anytime you have the time, this is going to be relatively easy. Since I have the time there, and I want to know the speed of the projectile at 4 seconds, that's going to be right about here. Recognize that it has a Vx and a Vy. The Vx... Oh, no, this one's more complicated. No, I'm not going to give you that problem. Okay, can we just... I'm surprised I gave them that problem, actually. What was this? 22? I'll check it. Let me write that down. So fall 22, number 2. I don't think I put it on the quiz, but I'll let you know if I did, or I'll just take it off if I did. But not on the quiz, okay? All right. Other particular questions? Huh? Well, the test questions are all new, right? So, no, it's not going to be on the test, because all the test questions are new. I don't reuse test questions. Quiz questions I reuse, but not test questions. Other questions, y'all? Y'all feel okay about this quiz? Okay, all right. Well, I think we'll stop there. I know that's short.